Democracy is often described as the fairest system humans have ever created, yet mathematics reveals a deeply uncomfortable truth beneath the surface. The problem is not corruption, ignorance, or lack of education, but something far more fundamental. The very systems we use to turn individual preferences into collective decisions contain logical flaws that cannot be fully fixed. These flaws exist even when voters are perfectly rational and honest. At the heart of democracy is voting, and one of the simplest voting methods is majority rule. In this system, each voter selects a single candidate, and whoever receives the most votes wins. This approach feels intuitive and fair, which is why it has been used for centuries across many societies. However, simplicity hides serious weaknesses that only become visible when more than two choices are involved. One major issue with majority voting is that it does not guarantee the winner represents what most people actually want. When several candidates compete, the vote can be split in ways that allow a less popular option to win. This creates situations where a majority of voters preferred someone else, yet the system still produces a different outcome. This problem becomes especially clear when similar candidates run against each other. Voters who share similar values may divide their support, unintentionally helping a candidate they strongly oppose. As a result, people begin voting strategically rather than honestly, choosing the option they think has the best chance to win rather than the one they truly prefer. Over time, this dynamic pushes political systems toward fewer choices. Smaller parties struggle to survive because supporting them feels risky. This natural pressure causes politics to collapse into two dominant groups, even when public opinion is far more diverse. The system itself rewards conformity and punishes nuance. To solve these issues, alternative voting systems were proposed that allow voters to rank candidates instead of choosing just one. These systems aim to capture more information about voter preferences and reduce the risk of wasted votes. In theory, they offer a more accurate picture of what the public wants. Ranked voting changes how elections work behind the scenes. If no candidate receives a majority of first-choice votes, the weakest candidate is eliminated and their votes are redistributed according to second choices. This process continues until one candidate reaches a majority. On the surface, this appears to fix many of the problems of simple voting. This approach also changes how candidates behave. Since second and third choices matter, extreme negativity becomes dangerous. Candidates are encouraged to appeal broadly, cooperate, and avoid alienating potential supporters. In some cases, elections become noticeably more civil. Despite these benefits, ranked voting introduces its own paradoxes. In certain situations, a candidate can actually benefit from losing support, while another can be harmed by gaining it. Outcomes can reverse in ways that feel completely illogical, even when voters act consistently. These strange results led mathematicians to study voting systems more deeply. They discovered that collective preferences do not always behave like individual ones. Even if every voter has a clear and logical ranking, the group as a whole can end up with circular preferences and no stable outcome. This realization led to the development of social choice theory, a field dedicated to understanding how individual decisions combine into collective ones. Early researchers proposed systems based on points, rankings, and pairwise comparisons, but each solution introduced new problems. Some methods depended heavily on how many candidates were running, meaning irrelevant options could influence the final result. Others produced endless cycles where no option clearly defeated the others. These contradictions were not accidents. They were built into the logic of collective choice. The most significant breakthrough came when mathematicians formally defined what a fair voting system should do. These conditions included respecting unanimous agreement, avoiding dictatorship, producing consistent results, and ignoring irrelevant alternatives. Each condition seemed reasonable on its own. The shocking discovery was that no ranked voting system could satisfy all of these conditions at the same time when more than two options exist. This result became known as an impossibility theorem, and it fundamentally changed how economists and political scientists understood democracy. This does not mean elections are meaningless, but it does mean perfection is impossible. Any voting system must sacrifice at least one desirable feature. There is no flawless way to convert individual preferences into a single collective decision without contradiction. However, This conclusion does not mean democracy is doomed. In many real-world situations, voter preferences tend to align along a single spectrum, such as left to right. Under these conditions, majority outcomes often reflect what most people want, avoiding many paradoxes. There are also alternatives to ranking systems entirely. Rated voting allows people to score candidates rather than order them. This gives voters more freedom to express approval without fear of wasting their vote. Evidence suggests these systems reduce polarization and strategic manipulation. Mathematics does not argue against democracy itself, but it does challenge our assumptions about how it works. Understanding these limitations helps societies make better choices about electoral design. Democracy is not a machine that automatically produces fairness, but a tool that must be carefully engineered. Even with its flaws, democracy remains one of the best systems available. Its strength lies not in perfection, but in adaptability. By acknowledging its mathematical limits, we can design systems that are more transparent, resilient, and representative of the people they serve. In the end, democracy is not about finding a perfect answer. It is about managing disagreement in a structured way that avoids violence and preserves freedom. The math may reveal its weaknesses, but it also helps us understand how to improve it.